In this video we've got a function f of x, and we want to evaluate it for f of -4. Now a little bit about function notation before we do this. F right there, that's the label for this function right here. It's just representing this rule right here, 3x squared plus 2, all this stuff. Now the number in parentheses, that represents the input, so that's going to be basically what's taking the place of the variable in this function right here, which is x. So with that said, let's go ahead and rewrite this function. It's going to be 3, and then instead of writing x, I'm just going to do open parentheses because I'm going to have to substitute a -4 in right here for this x and this x right there. So I'll continue to write this out. And now, like I just said before, I want to substitute in this -4 because that represents our input right there for the x, and then it also will go right there for the x. And that's it. Now we just have to simplify everything. So we got to follow order of operations. First, we want to do the exponent, so it's going to be -4 squared. So we're going to be left with a 3 times -4 squared is positive 16, and then plus 2. Now be careful, if you do this in a calculator and you just write -4 squared, it's going to probably give you a -16, which is incorrect, of course. We want to square a -4, so -4 times -4, we know that that's going to give us a positive 16. The calculator reads this as 4 squared, and then it happens to make that answer negative. So keep that in mind whenever you do these problems. That's going to be over -4 plus 29 is going to be a positive 25. So now let's simplify all this stuff up there. We've got 3 times 16, and that's going to be 48. So we've got 48 plus 2, and that's over 25. Keep simplifying, so 48 plus 2 is 50, and then that's divided by 25, so 50 divided by 25 is 2. So we know that f of -4, written up there, is going to equal 2, and that's our final answer. Now we've got another problem here in example 2. We have g of x, so that's going to be a new function called g, and then the input value is going to be 5/2. So we have to plug in 5/2 every time we see an x over here. So like I did before, I'm just going to rewrite my function and then keep parentheses wherever there's an x, because I want to sub something in to that x. That's our input value. So for our x value, we know that we need to plug in 5/2. So that gets done like that. And then I'm going to simplify. Still have a negative out there in front. We want to cube 5/2. So we want to raise 5 to the 3rd power, and then we also want to cube that 2 right there. Simplify a little bit more. So 5 cubed is going to be 125, and then 2 raised to the 3rd power is going to be 8, and then we also want to subtract 2. Okay, now we've got a denominator of 8 right here, and then this has an invisible denominator of 1. So we can't subtract these two numbers because we have different denominators. So we got to come up with the common denominator for these two fractions. So to come up with the common denominator, we have to find the least common multiple. So that's going to be 8. So if we want to change this 1 to an 8, we have to multiply it by 8. If we multiply the bottom part by 8, we also have to multiply this top part by 8, because 8/8 is just 1. So it's like if we multiplied 2/1 by 1, so that doesn't change the value, but it is just going to change the way it looks, and that's okay with us. That's actually what we wanted to happen. So we still have -125/8, and that's going to be minus 2 times 8, 16. 1 times 8 is going to be 8. And now we could do this subtraction. And we only subtract technically the numerator. So -125 minus 16 is going to be a -1 41, and that's still over 8. Can we reduce this at all? I don't think so. So that's going to be our final answer. And actually we could write that as g of 5/2, or 5/2. That will be our final answer right there.